Case 1 is known as constructive interface, while case 2 is known as destructive interface. Reflection and refraction of waves. Boundary. The plane or interface which separates two media is called boundary. For example, here shown in the figure, air-water boundary. Here in the second figure also boundary is shown between a string and the wall. When wave propagates from one medium to another medium, then at boundary, reflection and refraction of wave occurs. If the boundary is rigid, then reflection of wave takes place, while if the boundary is not completely rigid, then a part of wave is reflected and a part of wave is transmitted into the second medium. It's called reflection of wave. Wave follows the laws of reflection and refraction. Reflection at rigid boundary and open boundary. yi x comma t equals to a sin kx minus omega t represents incoming wave, incident wave. Then yr x comma t reflected wave, a sin kx plus omega t plus pi equals to minus a sin kx plus omega t. Here it is shown rigid boundary. And at open boundary, yr x comma t equal to a sin kx plus omega t plus 0 equals to a sin kx plus omega t. Now stationary waves or standing waves. The waves formed by the superposition or resultant of two progressive waves moving opposite to each other on the same line is called a standing wave or a stationary wave. Unlike progressive wave, they do not travel either way with time. In this wave pattern, the amplitude varies from point to point, but each element oscillates with same angular frequency. Note the point at which the amplitude is always zero in wave pattern of a standing wave is called node. Antinodes. The point at which particle oscillates with maximum amplitude is called antinodes. Expression for standing waves. Consider a wave traveling along the positive direction of x-axis and a reflected wave of same amplitude and wavelength into the negative direction of x-axis given by y1 x comma t equals to a sin kx minus omega t, equation 1, and y2 x comma t equals to a sin kx plus omega t, equation 2. By the principle of superposition, resultant wave is y equals to y1 plus y2, a sin kx minus omega t plus a sin kx plus omega t, equals to a into under bracket 2 into sine into kx minus omega t plus kx plus omega t by 2 into cos kx minus omega t minus kx plus omega t by 2 equals to 2a into sine kx into cos omega t, equation 3. Equation 3 represents a wave with amplitude 2a sine kx and angular frequency omega. Normal mode. The boundary condition restrict the possible frequencies or wavelength of the system in a standing wave. It cannot oscillate with any arbitrary frequency but by a set of a special frequency called normal modes of oscillation.